All right. So we are starting today's fifth and sixth grade Math Kangaroo Study Circle. So I'm going to share my screen and we'll start solving the fifth and sixth grade lesson 2 lesson plans. You guys are able to see the screen?
Yeah.
Yes.
Yeah.
Yep.
And you should be able to annotate on the same screen in solving some of these. So what I would encourage you, because we don't have our student population today, except Priya, read the question, um, explain the question in such a way that you are thinking about this question, call out on what is the problem, call out on what is your thought process on how you would solve it, and solve it on the screen for us. Okay? Make sense? Okay. All right. So we'll start with Harry. Do you want to take this?
All right. So the first question says that we need to draw the piece that completes the pattern. So the first thing that we should look at when looking for any pattern is whatever the first set of numbers or pictures that we have is. So in this case, get the annotated stuff out. I want to look at this first row, try to see what the pattern is. So for this, we know, so we have some circles. I think you tabbed.
Yeah, something
Oh,
else
sorry.
pulled up.
Sorry, something. Sorry, go ahead.
We have these circles right here, and we have what appears to be an arc, and then we have another arc and a circle, and then we have a circle here. But instead of an arc, we have a star, and then we have an arc up here. So if we look, we have star, circle, arc, circle, arc, circle. And then, so we have, hold on. So we have on the top row, we have a star or a little pointy thing, and a circle. Then we have a circle, and an arc, and then an arc, circle, circle, arc, arc, circle. And then if we look here at this row, we can see that we have a circle and an arc. So there's only two places this could happen, which is here or here. And if we look at where the star is, which is right here, and then we look at the fact that there's a circle, we could see that there must be a star here, complete the pattern. Must be a circle here, a star here, and an arc here. I just realized that you could have just filled this in because they're 3/4 of all the shapes already printed, but
Right. Yeah. So that's the second thought, right? I mean, when you solve a problem, there is a straight, basic way to solve it, and then once you realize the pattern, right? There is a much faster way. So I think that's why this problem is like, complete the pattern because there is a pattern. So yeah, you're right, Harry. Yeah, absolutely. Okay. I'm going to move on to the next one unless someone has questions. Right. All right. So this lesson was going to introduce, topics around patterns. And we all know what a pattern is, right? Rain, would you like to cover this slide? Just go through this slide and explain what this lesson is about.
Yeah, sure. As it says in math, or in general, a pattern is a repeated arrangement of numbers and shapes and colors. If there's like a rule, and they all maybe they all increase in the same way or they decrease in the same way, it would be known as a sequence. And you can express this mathematically, or you can kind of just guess it intuitively. And it can, depending on how you're applying it, like maybe it's in a real life application, or maybe they give you the pattern and you're supposed to complete it. It can, as it says there, be related to any type of event or object.
Wonderful. Thank you. So let's go Right, Arav, would you like to take this slide?
Sure. So patterns, as we know, can be found everywhere in seasons, days, plants, animals, crystals, pretty much everything. Some kind of patterns that can be found in nature or just anywhere could be the Fibonacci, fractal, spiral, and Voronoi.
Does anybody know what each of these patterns mean? We may not.
I know the Fibonacci, it's like the Fibonacci sequence.
Mhm.
That's
Yeah.
also the only thing I know is like the Fibonacci sequence. You add the
I never
number before it.
Other than
But I think like a spiral is just a spiral. I don't know like the patterns mathematically. I
Harry?
just like know how to identify them.
Oh, sorry. Yep.
Mm.
I think
Okay.
Fibonacci. Yeah, go
All
ahead,
right.
Harry.
So I'm gonna fill in the other two.
Yeah.
Since no one seems to know them. A fractal pattern is one that starts with some kind of fraction, and then the fraction repeats inside of the fraction. So if you have 1/2, over 1/2, over 1/2. And a Voronoi pattern is one where you have a certain amount of points on I'll use a piece of paper, and then each point is connected with two lines. And I'm pretty sure there's a picture of one on some of the slides in the future.
Okay.
I
And
just
I think
wanted to add,
spiral. Yeah, go ahead.
it's pretty interesting if you like search up a video of the fractal ones, because you can see that they start with this like large image and then they zoom into one section and then that large image appears again in that small section, and it's just like keeps zooming in and it's the same image over and over.
Interesting. Rain?
There's also Pascal's triangle if you want to check it out. It's highly applicable in later algebra, but I think it's really cool to just like look at it independently if you want.
Yeah, there is a pattern to the Pascal's triangle too, right? Yeah. And I think, the nature, as Ara was saying, right? It's visible in animals, plants, crystals, right? So the most interesting one, like, on the shells of the clams, right? You can see that spiral going on and on, right? Which is, I think, is the blue image in the middle, something similar to that. Priya, did you have anything to add?
I just wanted to say I think like we see patterns. So like we see patterns without even thinking it. It's like how we use math without even like thinking about it, or like there's forces that we're applying that we don't even think about it. Like right now I'm sitting in a chair, so I'm applying normal force, I'm applying applied force when I'm pushing a pencil, and I'm technically still on Earth because of gravity. Like there's so many forces that we don't even know about, but like they're there. One very cool fact that I learned in science yesterday is that when you're kicking a ball, technically the ball is pushing back on you, but you apply so much force that the ball moves. I never
Mm-hmm.
even thought about all of that. So
Yeah.
it's
So, Priya,
fascinating.
sorry to interrupt you, right? So, with that background, why do you think it's important for us to look for patterns in solving math problems? How is patterns and math related? What do you think?
It makes a problem easier because once I learned about all of these problems, I went back into a math book that I thought was extremely difficult when I was in 5th grade, and once I went into 6th grade, I started doing it again. And since I saw it with a totally new perspective, everything became a whole lot easier.
So, you
I think
started noticing patterns. Is that what you're
yeah,
saying? Yeah.
I think it
Exactly.
makes everything easier
Right.
in
Yeah.
a way.
So, like, okay. So, is there a pattern to this? What is this supposed to be?
For me, it just looks like a flower that's bending down.
Hmm.
It looks
Are
like
the
a sideways face.
There's
sideways
actually
what?
a pattern among all the shapes.
Oh,
Harry?
Wait,
They all have 6 sides and angles.
yeah. That is
Right. And I think the other pattern is they're all purple. Can we say that too?
yeah.
Right? Yeah. The color, the texture. Yeah. So that's an example of a pattern. I think, what's this? The pattern here is there's nothing there.
It's
I guess.
completely black.
Yes.
Yeah. I don't know. This is a funny one. Do you guys see any patterns here that
This is similar to a Veroni, where everything's connected by 3 points instead of 2.
Oh, so this is the Varuni pattern. Okay, interesting. So is it maybe your brain? Is there any correlation to how the neurons are
I
connected?
feel like it looks like pebbles on a beach.
Mhm. Yeah.
Like with the pebbles, like yesterday we went rock hunting and there were
I
big
just
rocks.
like it looks like I'm just walking in New York City and there's this one fancy restaurant with this wall.
Could be. That could be an inspiration. Yes.
Reminds me of art. There was a banana taped on a wall that was sold for over $500 million. I still
That's
don't know.
interesting. Yeah. Okay. So, Dipali, do you want to take this slide?
Yeah, so in the Math Kangaroo exam, they're mainly going to cover number patterns, color patterns, and image patterns. And for the 5th and 6th grade level, they will get a little bit more complex. So as everyone has already been saying, pattern recognition can help us like save time, and it helps make the problem a lot easier because it's like instead of saying you're going to add 32 times, you can just do 2 times 32 and then it makes your life a whole lot easier. So whenever we see a problem that might seem like it's going to take forever at first, we might want to look back at the problem and see, is there any way I can find a pattern so that I can solve it quicker?
Thank you. Okay. Harry, would you like to attempt this?
Sure. Zoja is drawing flowers of different colors. The first flower is blue, the second white, the next one red, the next one yellow, and again blue, white, red, yellow, and so on in the same order. What is the color of the 29th flower drawn by Zoja? Now, when I look at this problem, the first thing I want to do is determine how long is the pattern. So if it says the first flower is blue, the second flower is white, and the next one is red, and the next one is yellow, I know that the pattern is 4 long. So there's 4 numbers in the pattern.
The second thing I want to determine is how close
Whatever our goal number, which is 29, is to a multiple of 4. So what I would do is I would see 4 times 1, which is 4, is 4 times 2, which is 8, and so on and so forth, until I get to something I like 4 times 5, which is 20. That's a lot closer. But I can keep going, and I can say 4 times 7, which is 28. Now 28 is very close to 29. And I can start counting from 29 and keep going in the pattern. So if the first flower is blue, that's going to be +1. And there we can determine that the 29th flower is blue. Someone could probably do a better explanation then.
Anybody thinks that is not the right answer?
No,
I think that it is the right answer, but I had a much easier method of doing it.
Okay. Priya, hold on to your method, right? Does anyone else thinks it's not right? Or everyone got the same? I think everyone got the same. Okay. All right. So go ahead. Thank you, Harry. Go ahead, Priya.
So basically what I did was very similar to your method, Harry, but what I basically did was say that since it's 4, I just did 29 divided by 4. So I had 1 as a remainder, so it's technically 1 after the pattern. And the reason I'm not annotating is because I cannot see the annotation option. Zoom doesn't like me today, like most of the time.
Yeah. So it's a slightly advanced way of what Harry has shown us, right?
that's
So
great.
yes, your approach is very helpful when they say not the 29th flower, but maybe 222nd flower, for example, right? So that's the advanced way of how you can use that information of finding by division how many where in the pattern that I supposed to jump into. It will be helpful for bigger numbers. Yes. Yeah. Cool. Rain, did you have anything to add? I see your hand is raised.
Oh, yeah, I just wanted to say that both methods are probably the most efficient way. But you can also consider factors. I think because if we have a pattern before, and you kind of just have to go backwards. And since 29 is like a prime number, it's only divisible by 1, and blue is the first step. You can guess it from there, if that makes sense. I can elaborate.
That is an interesting way to think. Yes. I think is that somehow an extension of, Priya's way of, finding dividing and the reminder, right? Of Harry's first thought of what is my pattern size, which is 4, right? Now you divide 29 by 4 to get a reminder 1, and now you know that 1 is the blue, right? So it's a very interesting way to think about. Yes, yeah. Yeah, I think, I mean, Priya, you already know this, right? I mean, there's so many different ways to solve the problem. Now, the beauty is, as you solve more and more of these problems, you'll figure out what is the most efficient way, right, for the next one.
I
Cool.
think it's because of all the test practices I had to do. Like my parents, they made me do like 10 tests for number sets every single day. So it's
Mhm.
basically 10 minutes to solve 80 questions. You have to solve as many as you can skip, or else you get like -4. So I had to practice and practice and practice.
Mhm.
I still made a 6th place for some reason. But yeah,
Okay.
I
Thank you.
think it's just because of that.
Thank you. Yep. So Ara, would you like to solve this?
Sure.
Use
And
the annotation, okay?
I'm on a computer, so it'll be really hard to see because I have to draw by the mouse, which won't be good.
Oh, okay.
I
Okay.
can draw.
Dipali will be your scribe, okay? Or do you want
so
Dipali to take this, Ara? Dipali, why
Yeah.
don't you take this? Yeah.
thank you.
Okay.
So the way that I would approach this is, I noticed already that if you can combine. Oh, wait, let me just read the question for a second. The picture on the right shows a pattern of hexagons. We draw a new pattern by connecting all the centers of the neighboring hexagons. Which of the figures below do we get? So the way I would do it is, first of all, I would recognize that 3 neighboring hexagons, if you would connect their centers, it would form an equilateral triangle. So yeah, like that. And then the only one which is like a really big triangle and has many equilateral triangles in it is C. So that's how I would get C, if that makes sense.
Yeah, it does make sense. So, you use the concept of patterns in, first of all, coming with, the very first triangle, and then you extrapolated that as a pattern to the remaining part of the image, right? So that's how you use the concept of pattern identification. And then you look like which ones have the triangles, like the A also has a triangle, just like C, but you need a lot of those.
It's we have way more than 4. As if you could draw the entire thing, we would have way more than 4 triangles in total.
Correct. Yeah, they could have made this little harder by giving it like couple more shapes like C, but with the number of layers being different, right?
Yeah.
That could have forced you to count like how many layers do I need in the answer to be. Yeah. Cool. Anyone else has thoughts, suggestions?
One thing that I would warn about when tackling a problem like this is a trick answer like E, because maybe you don't notice, maybe you're looking at this, you're trying to solve it too quick, and you don't notice that you need the corner. maybe you think that you don't need the corner and then you end up selecting this answer. So it's really useful to just look at the edges of your problem and then tackle the middle.
Very true, right? Don't jump to conclusion. Verify that
The way
what you're
that
choosing
I
is
did,
actually.
I started on one of the corners, and I figured out that there was a triangle, so I basically eliminated E using that method.
Right. That makes sense, Arav.
You start
Okay.
from just eliminate, and D is just wrong because it's the same example.
Yeah.
And I don't know what B is.
It's lines.
Yeah, I know, but
Like how
So,
my teachers would explain, it's lines of boringness.
right. So moving on to the next one. Rain, would you like to take this?
Sure. So, they kind of they give you the like the pattern for this in this case. So they represent it algebraically. And we'll annotate and okay. So if we know that taking this picture that we have on the side, if we sorry. Okay. So if we take this picture we have on the side, then we can, we can use the formula they give us to plug in the values. So here, z would be equivalent to 6 and x would be equivalent to 5. So if we wanted to plug that into the equation, we use text for this. We would get 6 equals 5 plus y over 2, and then okay, and then you can kind of solve it like an algebra problem. So you multiply both sides by 2, so you get 5 plus y, and then subtract 5 from both sides, so you get y equals 7.
we're supposed to find the number that's on the top of the pyramid.
Oh, I don't think she's done. Are you
Yeah.
done, Rain?
Yeah, sorry, I was just like, just in case anyone had any questions, sorry, I should have specified.
Thank you, Arav.
Then you can use this value and build your way up. So now we know that now since we know what this value at the bottom is, we can use the triangle again. So now this is our x and this is our y, but it's a little simpler in this case because we don't have to mathematically like rearrange it. We can just do 7 plus 9 divided by 2 as it says over here, which is obviously 8. So then we have 8 over here, and then again, since we have both of the values on the bottom, 6 plus 8 is 14, and then you divide by 2, so that's 7. So it's important to always start from the bottom in these kinds of problems, because there's just no other way or I guess there could be a way, but right now it's like a lot easier to find when you have one unknown versus like 2 unknowns, how we did at the start if we wanted to start at the top.
Arav, is that the right answer?
Yeah, I got that same answer.
Okay.
Me too.
I have a different
Okay.
way to do the problem.
Sorry, who is that? You, Arav, speaking? I heard a couple of people speaking.
Yeah, that's true.
Okay.
So, can you please erase all this?
Is it a different way, Arav?
Yeah.
Okay.
Yeah.
One thing while that happens, right?
Erase that.
Typically
Oh,
the answers are multiple choice, right? So do you think like if we have a multiple choice, is it one of the
test should be multiple choice.
yeah.
So they'll give you options, but it'll still remain the same way.
Right. Okay. Go ahead, Arav.
So my way of doing this would be multiply. So first I would start off with 6, multiply it by 2, which we would get 12. And then we have to figure out what two numbers add up to 12, but we already have one of them. So 5. And so I did 12 minus 5, and 7 was in the middle bottom box. And then I added 7 plus 9, which is 16, which goes in the right box in the middle row. So that it's not actually 16 because you have to divide it by 2 as shown in the formula. So
So sorry to interrupt, Arav. So your method, you're doing mostly the mental math, right? Basically,
yeah, basically.
that's the difference, right?
Mhm.
Yeah. Okay. Cool. Awesome. Thank you.
I have
Harry,
a faster
I
way
see
to
your
solve it.
yeah. Go ahead.
Okay, so
Yes,
hold on, let me get my annotating
you
out.
can hear us.
If you notice right
I
here,
don't think Priya can hear us.
You can hear us.
Oh, Priya can't hear us. I will respond to her.
Is anyone even talking? Because for me, I can see people talking, but I can't
Hi,
hear them
Priya.
talking.
Yes.
Like the only thing I can see is annotations.
Hmm.
Should I just try leaving and then logging back in?
Yeah.
Okay.
Right. Go ahead, Harry.
all right. Anyway, the faster way you can do that, if you notice, this is kind of like an averaging equation. And the thing with averaging equations is you don't have to go up all the way to the pyramid. This is just a long way of doing the average. So if we notice through both Rain and Aro's method that this number is 7, we can actually just take the average of 5, 7, and 9. So 5 plus 7 plus 9 over 3. 5 plus 7 plus 9 is 21, and 21 divided by 3 is just equal to 7. So then we could determine that the top of the pyramid is 7.
Yeah. That's also
That
another
is
one.
brilliant.
And actually, if you wanted to cut it down another step, you could just notice that the average of 5 and 9 is 7.
That is
So
brilliant because it always leads to the average.
yeah,
Isn't that amazing, guys?
That's what the method you should do if it's like it's really big. Then you could take the average. So it can save you a lot of time. And even in this, it would save you more time.
the issue with it being bigger though is because you have more unknowns, so you would just have to figure everything out at the bottom. But when it just has 3, you can just determine that it's 7.
I think this is the true power of identifying the pattern, right? It's not just the small pattern between each 3 numbers, but the overall pattern of the entire pyramid itself,
Okay.
right? Which is the average.
I
Yes.
can hear y'all now.
Can you hear us now, Priya?
Yeah.
Okay, excellent.
I think it's just because my Zoom, I don't have the app installed.
That's okay. That's okay.
Okay.
So, all right. So, you know the answer to this. Harry just gave us a brilliant way to solve this, Priya.
Yeah, I heard it. It's like taking the average out of them.
Thank you, Harry, for that insight. It's brilliant.
No problem.
Okay.
Yeah.
All right. Priya, would you like to solve this?
Okay. I finally found the annotation option. My iPad. Since I logged in with my iPad, I normally log into Zoom meetings with my computer. I couldn't see it. Oh, great. Now it's gone again. Anyways, can someone else do it for me?
Dipali
I-
can do it for you. Go ahead. Or Harry, you want to do it?
I don't care.
Okay, yeah.
Okay.
So the positive integers have been colored red, blue, or green. One is red. Green calculates the sum of blue number and a red number and a blue number, what color can be what color? So if I so if we say, because 1 is red, 2 is blue, 3 is green, so we could take 1 and 2 and it would make a green number. So if we do 1 plus 2, it would make 3, so it's a green number. But just to check my theory, I'll do 4 plus 5, which is equal to 9. So 4 is red, 5 is blue, 6 is green, 7 is red, 8 is blue, 9 is green. So the number of the resulting number has to be green. I think that's the answer. The color of the resulting number has to be green.
That answer is correct. And also, here's another way to like really explain how it will always result in green. So red will have 1 and then blue is 2. So it always adds by so say the first red number is 1, the second red number would be 3 more than 1, which is 4. So and that would be the same for the blue and green. So basically if 1 plus 2 equals the first red and the first blue equals green, then all of the other ones will be a multiple of 3, and that would also result in green, if you understand.
Yeah. Well, I think it kind of makes sense because if you add something that's red and blue, the only color that you have left is green.
Yeah, but don't get fooled by these problems because a lot of people think that there could be a lot more ways of adding up red and blue, and they calculate all of the other ways, which is like a lot more they calculate. So just try and save time on these problems because these are the ones that take up most of the time from people.
Thanks. Harry, what do you have to add?
You can solve this problem potentially even faster. Hold on, let me get this off the marker. If you notice, it says what color. There's no S here, so that means there's only one option. If you notice, you read the problem at the beginning, red, blue. You can immediately say that 1 is red, 2 is blue. So 1 plus 2 is 3. So whatever 3 is must be the answer for all of them. Because it states that the color instead of colors, so there's only one answer.
Oh, okay. That's how you know it can only be one number, one color, basically.
Yeah.
Ah, that is perception, right? Reading into the, I don't know who that is. But that is ours, yes. Sorry, there's somebody at the door. Yeah. Cool. Brilliant observation there. Okay. Dipali, would you like to take this?
Sure. So this one says Peter went hiking in the mountain for 5 days. He started on Monday and his last hike was on Friday. Every day he walked 2 kilometers more than the day before. When the whole trip was over, his total distance was 70 kilometers. What distance did Peter walk on Thursday? So we can split this up into a diagram. So I'll just say on Monday, Tuesday, Wednesday, Thursday, Friday. And we'll say that when he started on the first day, he hiked X kilometers. So if every day he walked 2 more than the day before, then on Tuesday, he walked X plus 2. On Wednesday, X plus 4, X plus 6, then X plus 8. So all we have to do now is add all these up so that it equals 70. So we have 5x plus, that would be
20.
20 equals 70. And so we get x is equal to 10.
Mhm.
They're asking on Thursday what distance was walked. So we have to plug in 10 over here. So 10 plus 6 is 16.
Ara, do you have a different way?
No, this is the exact way I do it.
Okay. Thank you, Deepali. Harry?
Sorry, the unmute button was not working apparently.
It's okay.
Can you erase what you have on there real quick? I want to draw something. So DePauli did a really nice explanation for if you want to determine what a specific day was. But what if I wanted to determine, well, how much did you walk? Well,
It gives you how much you walked though,
sorry.
total, right?
Sorry, that's my fault. If you want to determine what's on Thursday, a little bit quicker, I'm just gonna draw the same thing. If you want to determine how much they walked, the easiest way is you have the total, so that's 70 kilometers. And you have 70, and then you divide it by the amount of days. So 70 divided by 5 is
14.
14. So if you have 14, you know that the average of the total amount walked is 14. So you can determine that on the middle day, you walked 14. And if you walked 2 more, then you walked 16 on Thursday.
Mhm.
Can we give a big kudos to Harry? Don't you guys think this is brilliant?
Yeah.
It is.
Yeah?
It's like when
Ara?
my mom, I figure out like the hardest way to do it. And my mom's like, why did you take so much time on it when you can do it like this? And I'm like, how do you think of stuff like this? How?
So Harry, how do you think about stuff like this?
Well, whenever I see patterns or counting, I like to remember that oftentimes you spend so long counting. I did this at the beginning, and I took a second to think about it when I was multiplying instead of just dividing and taking the remainder. If you take the average of a number, you'll always get into whatever the middle amount is. So if you can look for problems that are taking something similar to the average, you can always I don't know how much algebra I can write on here, but if you know that any number is a number, and then that's over the total, and then you multiply that by the number plus 1, and this is whatever number you're at, you'll always get the answer, and then you can make this by whatever you're adding to each part of the pattern. So if I was adding by 2, this would be number plus 2, and that can solve for any pattern. But the way I looked at this is just how can I get as close to that value as possible without having to go through every single one of them. And since it was pretty close to the middle, I took the average.
Awesome. Hey Rain, do you have something to add? I see your hand raised before.
Oh, no, that was a clapping thing.
Excellent. Yes. Right. I've just realized something. I mean, as a group, right? Um, I think our basic tendency is to fall back to the first thought or the first approach that we think we can solve, right? But I think that the struggle is to fight it and say always there is a better way to solve, right? And train our mind to think about what's the next best way to solve.
For me, it's just that whatever way that comes to mind at first, I just do it that way because it takes more time thinking of another way than it actually does to solve it the way that I already have in my mind. So I just do it the way that I have in my mind as fast as I can instead of thinking of another way. because it just takes too long for me to think another way.
Yeah. Yeah. So, but there is always time for us to dedicate to thinking beyond the obvious, right? Obviously, the Math Kangaroo competition day is not such a day, right? We are not asking you to think out of the box on that day. Harry?
And one thing I want to say, Arif, is I agree with you, and I would just do the first solution that comes to mind because it would work most likely. But explaining the long way of doing it is often a lot harder to understand than trying to come up with a simple, neat, straightforward way of doing it.
True.
Giving them a process they can follow.
True.
That is one thing I am horrible at. I can't explain anything. I can just do it.
Yeah, that's one thing that I have. I can
Right.
do it every single
Yeah.
problem that you want me to in this thing, but it's
Yeah.
really hard for me to explain it.
Yeah. So, you should really thank, Harry, Rain, Dipali, of course, Arav, right? Just this kind of time that you spend with each other is how you inspire each other and prove that, there's more, right? There's more farther
Yeah.
you can go. Yeah. Cool. Awesome. So, Rain, would you like to try this?
Sure. So on Monday, Alexandra emails a picture to 5 friends. For several days, everybody who receives the picture emails it the next day to 2 friends who haven't received the picture yet. And on which day does the number of people who have received the picture become greater than 100? So if she sends it to 5 people and then each of those people send it to 2 people, it's another pattern. So if you just draw this out, say this is day 1, day 2, and as in day 1 after she sends it. So I guess this would more be like day 2, and this is day 3. But that's day 4. But I think you get what I mean. So 5 times 2. So if we start with 5 people who would have gotten it, and then the next day we would have 5 plus 5 times 2 because everyone sends it to 2 people. Sorry, I think I'll just explain aloud because I'm using a trackpad right now, so my annotations don't make a whole lot of sense.
That's
But
fine. Do you want anybody to draw it for you, or you can go ahead? I mean, we are following you.
so 5, and then we have 5 plus 5 plus 5 times 2. So now if we have 15 people who have gotten it, or here, let me just erase all this actually. So then we keep going with 5 plus 5 times 2, so that's going to be 15. Then everyone, next day, if all those 15 people, and I'm not sure if they mean like the receipt. Actually, does anyone know if they mean sending it like they only send it out to another 2 people the first time they receive it, or just in general after receiving it they always
The
send it out?
first time. They mean like the first time.
Oh, okay, thank you.
Harry?
For people who fall into this trap, it says that they sent it to 2 friends who haven't received the picture yet, and it says everyone who receives the picture. So if you sent it, but you didn't receive it, so the original 5 won't send it, but then 10 people will send it, but then 15 people will send it. So it's really, or not 15, 25 people will send it. So it's not a straightforward pattern, actually. I think this problem was just worded poorly.
No, it would be
I
first
literally
5
just
people would send
realized
it, then
I
10
did
people
the
send
same
it.
thing.
Hold on, guys.
They're all odd numbers.
Arav, can you go first? You started speaking first.
The first, the original 5 that Alexandra sent it to would send it to 2 other people that haven't got it. And then those 10 people who just got it from those 5 original people would send 2 more. And then those 20 people would send 2 more, and so on and so forth.
Wait, so I have a question. Would it be like
Mhm.
5 one day, the next day 7, the next day 9?
What?
No,
Mm.
I think the way the problem is supposed to work, ignoring how poorly it's worded, is that each time the amount of people who are sending it doubles.
Oh, so it's like 5, 10 plus 2?
Where are you getting the +2 from?
Because it says
It
2
should
friends.
be
What?
multiplied by 2, not added.
Oh, okay, yeah, now I'm
Times 2.
completely confused.
Yeah, so you can like express it as well, if you have 5 on the first day, 10 on the second day, and then you have 20 on the following day, you kind of just have a pattern that is like 5 times 1 plus 5 times 2 plus 5 times 3. So actually you can use a pretty cool trick with this. So I'm going to try annotating again. Tell me if you can't read it, I'll go back and fix it. But so it's kind of like that. 3 times 5 and so on, or sorry, not 3 times 5. It's the preceding number times 5.
It would be 4 times 5, right?
Yeah. So gosh, maybe someone else should write this out. I think I need to
Okay. Yeah. Harry, you want to try this?
Yeah, I can annotate this. Can you
Yeah,
clear what you
yeah.
have already? I'll make a little table too. So let's do 6 days at least. I'm just gonna write M for Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. I think that should be enough days. We have room to expand it if we need to. All right. Rain, do you want to start explaining so I can write down?
Yeah, so on Monday we have 1 times 5 people. Tuesday we have 2 times 5 people, and on Wednesday we have 4 times 5 people. So you're kind of just you're just multiplying, you're just doubling it each time. And then basically you can use something called the distributive property. So like for example, if you wanted to add 1 times 5 plus 2 times 5, that's the same as 1 plus 2, which is 3 times 5. So you get 15 as a smaller example, but you can use it on like a larger scale. So if you divide 100 by 5, then you get 20, and then you can kind of just count up from there. So you can go like 1 to 2 to 4 to 8 until you get 20, I believe. So yeah, or sorry, not start from 1, you start from 2. I think that's how it works.
It's starting to make much better sense now. So technically, the time it would be more than 100 would be on Saturday.
No, it would
'Cause
be
it's
Friday, right? Because 1
no,
plus.
because like no, 20 times 5 is equal to 100.
Mhm.
So it has to be more than 20.
Yeah, so 1 plus 2 plus 4 plus A is 15. And
So,
so that would be on Thursday. There would be 15 times 5.
Oh, hold on. I think this problem was explained incorrectly. That's why everyone's confused. So the reason I think it was explained incorrectly is because we're not including the people who already received the email. So I did write an equation for this, but then I'm just going to actually explain what it means because the equation is not, you know, 5th, 6th grade. So the equation for this problem is, oh, it is not like that. It is, hold on. It's not letting me edit my text. It's 5/2 times 2 to the x plus 1, I think. Hold
I
on.
think I found a way to do it.
Yeah.
Okay, let me explain. So on the first day, we only have, so we'll just call this Monday. So on Monday, Alexandra sends it to 5 friends. So far, we'll call this like the receiving, but however you spell receive. And then this one is like how many total, wait, number receiving the picture, and then like total, just like you have to add it as you go. So
Yeah.
on the second day, so here we have 5. And then on Tuesday, now since those 5 people each send it to 2 friends, the total received, I mean, they send it to 10 people. So the total is now 15. And then on Wednesday, the 10 people send it each to 2 more people. So that's 20. So 20 plus 15 is 35. And you keep going. So 20 times 2 is 40, 75. And then 40 times 2 is 80. And that's
155.
155, which is greater than 100. So on the 5th day, which is Friday.
Mhm.
Yeah.
Yeah, so the answer would be Friday.
Yeah. I think this problem is worded.
Oh, so you're decreasing 5 for each and every day.
Yeah, I think the weird part is that the people who have already received it keep on sending it. So
Well,
like the 5
Because
people
like
who
for
already
me,
received
what
it.
I did was like it's 10, 20, 40, 80, 160, but then I forgot to take the 5 out.
yeah.
So technically I still got Friday, but
But
I didn't solve it the right way.
Topoli, do you mind erasing so I can explain a mistake that I made
Yeah, sure.
when reading this problem? So when I read it, I saw that Alexander emails a picture to 5 friends. So 5 friends receive it on the first day. And then those 5 friends send it to twice as many people as there. So 10 friends received the second day. And then I saw there were 15 friends sending emails. So now there should be 30 people. Now there's 45 people sending emails.
Yeah,
So
I don't think it was like you. I
So
don't
the
think.
correct answer is Thursday, clearly.
Yeah, I don't think they meant to like keep on like the
Yeah,
people who've already sent it. The people who've already received it like don't send it again.
So I feel like we should email Math King
About this and have them fix the problem.
Which, I think we should.
So-
Yeah. Any
It's
other
interesting
closing
that-
comments? This is
it's
a good
interest-
one. This is.
Hold on. One other thing. It's interesting
Go
that
ahead.
they included the case where the same friend could email it to the same friend again, but they forgot.
yeah,
Like they clearly tested this problem, but
yeah.
I don't know.
They have to specify. There could be like 3 different answers, and people could explain it to how it could be correct. Or actually, there could be infinite.
And the
Yeah.
crazy thing is this was an actual problem on the 2018 test.
Way.
Yeah, and it the only reason I can guarantee that it's 155 and that I've just worded very poorly is because I'm looking at the answer key. Like I had to pull up the answer key to figure out this.
Yeah. Okay. Where are we with time? I think we are about 7:30. Um,
Yeah.
there are a few more, but oh, there's just one last one. So should we just wrap this up?
Yeah, sure.
Yeah. Okay. It's good. Arav, do the
Hmm?
honors.
Okay, sure. We have several square grids with odd numbers of rows and columns. All of the small squares in the grid, which are either in a row or in a column with an even number, are painted white. The rest of the small squares are painted black. Grids that are 1x3, 3x3, and 5x5 are shown in the picture. How many small white squares will there be in the grid that has 25 small black squares? So the way that I would approach this is, first there's a 1x1 square, so there would be a 1x1. Wait, can someone annotate for me, please?
Yeah, I can annotate.
Okay, so for the 1x1 square, there would be a 1x1 black. There would be 1 times 1, which is 1 black squares. And then for the 3x3 square, there would be 2 times 2, which is 4 black squares. And for the 5x5, there would be 3 times 3, which is 9. And continuing this pattern, the 5th square, which is a 9x9 square, would have 25 black squares. So basically, we do 81 minus 25, which would be 56. And that would be the answer. Did you guys understand how I got my answer?
Thank you, Arav. Hey, Harry, you have your hand raised.
I have a way of doing this that would be helpful for a much larger number if you're interested in that. So can you erase real quick so I can? All right. So if you notice here, it's the difference of two squares, and I would always like to visualize this as x squared minus y squared. So we have, and maybe this isn't the best explanation for this, but this is how I would view it. And then if I wanted to look at something that had 25 small black squares, all I would say is that is equal to 25. And then you can create a second equation
Where
x plus y is equal to 81. Sorry. Oh, I just cleared everything. But that's how I would have done it. It's not a super useful for this actually. So I'm gonna retract that.
I would do that exact same way if there was a bigger one, but for this one I would do it the way that I explained.
Yeah.
Oh, how would you get x plus y is 81?
So it follows typical right triangle patterns. So if you notice, you can just divide it in half into a right triangle. And if you notice for all of this, that 3/4 of all the squares are going to be white. Or sorry, not 3/4. No, it's completely I'm sorry, give me a second to figure out how I'm going to explain this.
Okay.
Okay.
Sorry. The easiest way for me to explain this is that you know how many black squares you are, and you can say that the black squares are y squared. And then if you know how many black squares then you are, you can say the total number of white squares minus the total number of black squares is going to be something squared.
Hmm.
Yeah, I'm gonna retract my answer. I forgot.
Yeah, that's okay.
I
That's
need
okay.
to do a review on Algebra 1.
Yeah, yeah, absolutely. Okay, cool, awesome. Wasn't this a brilliant session? You all, right? I think we should do more
That
of these.
Yeah,
was.
other than there were like no students other than Priya, it was brilliant.
Yeah, right. I mean, I think that gave you all a chance to look at every problem like really multiple different options. There's a huge learning experience for all of us. So I think it's brilliant, awesome. So we'll stop the session here, and then we'll meet next time. So what I'm going to do though is, I'm going to send a separate email to the parents of 15th, 6th graders to really vet out their interest because we have quite a lot of first and third, fourth graders joining, right? Like 10 of them.
I
So
think mainly because like this weekend there are lots of winter socials here. Like even in my school, they delayed it because the donations weren't coming
yeah,
in,
yeah,
and we had
that's
like this
okay.
drinking
Yeah,
contest where the Viking times were free. There was like a whole story, and I
right.
think it's because for some schools in Frisco, like their winter break is now, so they might have traveled somewhere they couldn't attend.
That
Like
absolutely
last
makes sense.
class,
So, yeah, so Priya, we're not going to cancel it. I'm just going to ask, like, hey, look at this recording. It's so brilliant, right? So, I'm going to encourage them to join and get their input. Like, if they're not going to join, we will actually blend this into the next one, maybe seventh and eighth. You know? Yeah,
okay.
cool,
Yeah.
awesome.
But if you
Well, have a great
wait,
weekend,
can you
everyone.
let
I
me
hope you had
know if you
as much
are
fun as I
going
had.
to blend it? Because then I have to
No,
change
no,
my
no.
schedule.
You will get an email if I'm going to do that.
Okay.
But I need some feedback from fifth and sixth grade parents before we do that. Okay?
Okay.
Yeah.
I actually just figured out my solution. I'm so sorry.
Oh, go ahead.
Okay, how I would have done it is I would have just figured it's the difference of two squares, where the total number of squares is twice the amount. Essentially, what I would have done, the most easy way to explain this is that for a normal difference of squares would be where you have one square, which is 1, and then you have this, which would have been 4. But this is actually, it happens twice as fast. So if you have a 5 by 5 square, or 5 by 5 of black squares, then you will be twice as far along with the white squares as you are with the black squares. Minus 1 because you didn't start out with 1. But that's not a really efficient way of doing that.
Wow. Okay. That is a whole different level of
Yeah,
looking at the
like
pattern.
you can see for the second block, the ratio of black squares to white squares is 4 to 5, and the whole thing is a 3 by 3. So you have the 3, 4, 5 right triangle, and then for the other one, you can see for the 5 by 5, the ratio is 9 to 16. So yeah, there's definitely that pattern there.
So it's just all 3, 4, 5 right triangles.
Yep, exactly.
Now I get what you mean by right triangle. Cool. Awesome. Excellent work. Thank you all for joining. We'll see you in the next week and following weeks, okay?
Bye.
Have fun, guys.
All right.
Bye.
Bye.